Hi everyone. In this session, we are going to learn about the product rule of differentiation. This is used when two functions are in multiplication with each other. And as you can see over here, that f of x is equals to f of x is equals to f of x times g of x. The f of x is, as you can see, this is a capital. I've written it in capital to show that it's a different function so that you don't confuse into the smaller f of x and f of x. So as you can see that this f of x is a product of f of x times g of x, and by the first principle we are going to prove this product rule that it is equal to the differentiation of the second function keeping the first function as it is plus differentiation of the first function keeping the second function as it is in multiplication. Correct. So this is how the product rule is defined. Also, you should keep in mind the condition. The condition is that the f of x and g of x should both be differentiable at x, or f dash of x and g dash of x should exist. This is the condition. And now I'm going to explain you by the first principle. So by the first principle, we know that differentiation of f of x is equal to f of x plus h, take away f of x over h, limit h tending to 0. Don't forget the limits. Now we can replace the f of x plus h with these functions. So f of x plus h times g of x plus h minus f of x times g of x divided by h tending to 0. Sorry, one second. Divided by h, and I should write limit over here. Don't forget the limits. So limit h tending to 0. This is how you will write it down. Now taking it further, I am going to add and subtract an expression which is f of x plus h times g of x. Now you know, if you add something and subtract something from an expression or an equation, there is no change in the magnitude of the equation. So that's why I am going to add and subtract this expression. So look clearly, limit h tending to 0, f of x plus h times g of x plus h, take away f of x, g of x plus f of x plus h times g of x, take away f of x plus h times g of x. So ideally there has been no change in the equation. So this is what a function would look like. Now I'm going to take a plus and a minus function to make it in order of the first order principle. Similarly, these two functions shall be taken together. So I'll take a different color pen just to be little more exclusive. So let me take a, like, let's say maybe this. Yeah. So now limit h tends to 0, f of x plus h times g of x plus h, take away f of x plus h times g of x divided by h, and then plus again limit h tending to 0, f of x plus h times g of x, take away f of x, g of x upon h. Right, now you can see that I can take f of x plus h common. So limit h tending to 0, f of x plus h in the brackets g of x plus h minus g of x over h plus limit h tending to 0, g of x common, f of x plus h minus f of x over h. Can you see the first principle coming over here? And now if I'm gonna put the limit h tending to 0, that means h is going very very small. So I am gonna get f of x times g dash of x, because this is what is called the differentiation of g of x, plus g of x as it is, and differentiation of the first function f of x. This is what looks like the f dash of x. By the first principle, we are successful in proving that. Now let us see how should we apply this in the questions. I actually left this space for me to, maybe that could be a long function explanation, but it got completed there on the first page only, so I didn't need this page. Now you can see that 3x squared times 2x plus 1. So you can see that this is one of the function f of x and this is the other function g of x. That means if I have to find the differentiation d by dx of the f of x, which is this, so what I'm going to do is the differentiation of f of x will be called as f dash of x. So let's keep the first function as it is. So 3x to the power of half as it is, but differentiation of the second function, which is 2, because the differentiation of 2x plus 1 is what, 2. Then plus, keep the 2x plus 1 as it is and differentiate the 3x to the power of half. So 3 times half x to the power of minus half is going to be the differentiation. As you know that d by dx of x to the power of half will be half x to the power of half minus 1, right, which will also be equal to half x to the power of minus half, can be written as 1 upon 2 root of x. X should be in the denominator because the power is negative. So this is what it is. Now 2 times 3 is 6 x to the power of half plus 3 by 2 root of x times 2x plus 1. I also wanted to tell you that when, let's say, you have got a function y is equal to u times v, then according to Leibniz, this dy by dx would be equal to u dv by dx plus v du by dx. This is how Leibniz gave the same thing, however written slightly differently. Again, u and v are the product and which is stored in y. So y is a product of u and v, and when you differentiate them, this is how it's going to come up. Again, next function, this is also a composition of two functions multiplied together. So f of x is the first one, second one I'm taking as g of x. So keeping the first one as it is, x square plus 1 as it is, differentiate the second. Now this is also in the form of root of x. So 1 upon 2 root of 2x minus 4. But you should learn over here the chain rule, which I have already explained in the first video. You can check that out. That differentiation of 2x minus 4 will also happen. So that will be 2. Okay. Now plus root of 2x minus 4 as it is, and differentiation of x square plus 1 will be 2x. Correct. So now let me just put a line. Finally, we have cancellation of 2 and 2. So x square plus 1 upon under root of 2x minus 4 plus 2x times root of 2x minus 4. That's it for this. Next one. Now here we have got an exponential function, and one of them, the other function is just plain cubic polynomial. So we can split into fx and g of x. So again, keep f of x as it is, e to the power of 2x as it is. Differentiation of the g of x will be 3x squared plus 3, plus keep the x cube plus 3x plus 1 as it is, and differentiate e to the power of 2x. Now the differentiation of e to the power of x is equal to e to the power of x. However, differentiation of e to the power of 2x will be also incorporating the chain rule, where the differentiation of e to the power of 2x is e to the power of 2x. However, the differentiation of 2x will also happen, which is 2. So look clearly, it is 2 e to the power of 2x. The final answer would be, take e to the power of 2x common. In the brackets, you can write 3x squared plus 3 plus x cube plus 3x plus 1. Right. This is how now your 3 plus 1 can be added together. So it's up to you to add them and write the final answer. I would just write e to the power of 2x and then 3x squared plus x cube plus 4 plus 3x. A little rearrangement would be required, but this is okay to be the answer. Let's move on to the next one. This is again f of x and this is g of x. Differentiation of e to the power of 4x. Now first let's keep f of x as it is and the differentiation of g dash of x will happen. That means the differentiation of g of x will happen, which will be g dash of x, and then plus g of x as it is, and differentiation of the f of x will happen. So e to the power of minus 4x remains as it is. Differentiation of 1 upon root x, differentiation of root x will be under root of 1 upon 2 root of x plus 1, and then differentiation of x plus 1 is just 1. So that's it. And then we'll go ahead plus keeping g of x as it is. So g of x is root of x plus 1. Differentiation of f of x, that will be minus 4 e to the power of minus 4x. Now let's take e to the power of minus 4x common. We will have half root of x plus 1 and plus, so when minus 4 will come outside, it will change to minus 4 root of x plus 1. So you can just pause the video, retry the question, and then only proceed further. Next. Again, now we are on to the circular functions. So I would like to make you aware that d by dx, that is a differentiation of sine x, is cos x. Differentiation of cos x is minus sine x. Differentiation of tan x is sec square x. Let's apply this over here. Now let's keep tan x as it is. So tan of 2x as it is. Differentiation of sine theta is cos 2x, but you also should know that you have to differentiate 2x also. So plus 2, I mean times 2. Then plus sine 2x as it is. Differentiate the tan 2x. That will be sec square 2x times 2. That will be the differentiation of 2x. So finally we've got the answer 2 times tan 2x cos 2x plus sine 2x and sec square 2x. That's it. This is it. This is your answer. Next, x square and e to the power of sine x. So let's keep x square as it is. Differentiation of e to the power of sine x is e to the power of sine x, but you should also know that you have to differentiate the sine x because of the chain rule. Differentiation of sine x is cos x plus keep e to the power of sine x as it is and differentiate the x square, that will be 2x. So the final answer will be e to the power of sine x and in the brackets x square cos x plus 2x. Next question. Differentiation of x square cos square x. So keep x square as it is. Differentiation of cos square x will be 2 cos x, and differentiation of cos x is minus sine x. Chain rule applied again. Plus cos square x as it is. Differentiation of x square is 2x. So this will be minus 2x square cos x sine x plus 2x cos square x. This is your final answer. Let me just finally check. 2 times x square and minus outside sin x cos x, correct hai? And 2x times cos square x, that is also correct. I think that's it, and soon we are going to see the quotient rule also. So I just hope you understood. If there are any problems, you can probably put in the comment section below and I'll just check them out. I think that's it for the video, and I'm going to see you in the next class.